Jelly, it just starts playing. So I just want to make sure that.
Mm. So, I mean, how deep should I go in AI, or is like I will just go in my flow and then go
I
deeper
think
the questions?
yes. Yeah, I think you can go like whatever makes sense for you. So
Hmm.
go ahead. So we have like 45 minutes, and then
Hmm.
like 10 to 15 minutes we can give for Q&A.
Hmm.
Yep. Cool. Awesome. Yeah, I think thanks everybody for joining back again. Hope all of you had a great Diwali. So we all are back from the festive mood and back to work again, right? So we have a very dynamic speaker who's a founder of a company, as well as she's has a lot of patents. She's a great speaker. She also authored 3 books and whatnot, right? So we have Anvita Bajpai, so who's the founder of Sun AI, and she's also authored 3 books, right? And she's actually an IIT Madras and IIM Bangalore alumna. She's got around 16 years of experience in MNC, helping companies to build smart products, right? Especially in the area of AI. That's what her interest is. To name a few, Oracle, Satyam, Wipro, and a lot of startups before she started her own company, right? So I'll let her speak what her company starts doing. But probably it's kind of India's first AI powered assistive tool for consumers who can try to confirming for the July 2020 enforcement of Consumer Protection Act. So it's kind of empowering all our citizens to for the kind of right of information kind of a thing, right? So yeah, that's what she's into. She's published n number of research papers and a lot of patents as well. And also her company's one of the USPs, like it's patent pending, so which is another big thing. And she's also very active in most of the conferences. I think it's very hard to miss out her. So she's an invited speaker in UX India Rise, which happened in 2 years back, AI Connect, and recently India Electronics Week and the Global IP convention as well, right? And the last section where she's also recipient of a lot of awards. Again, to name a few, she was a Golden Lotus award she won from IIT Madras Alumni Association for International Women's Day in yeah, a couple of years back, 2017. And her company actually won an award in GIPC award recently in this year for the excellent contribution made in the field of IP and innovation, right? And she's also a recent recipient award winner for the 51 Fabulous Global Smart Cities Leaders Award, presented by ET Now, right? And yeah, I think the list actually kind of goes on. So without wasting much of time, Anvita, so she's going to help us talk about AI and ML, at least from a designer's point of view, like how does it help us, right? And what all we need to know. Right, we do have a lot of information on that, but I think when it comes from an expert who's been there and done it, I think that's going to help us a lot. Over to you, Anvita.
Thank you, Than, for the introduction. And hello, everyone. Very good afternoon. So, voice is clear, right? Yeah. Okay.
Yes, all good.
So I will talk about AI ML for designers, and as we talk about this topic, any questions you have, please type in Q&A box, and we will take questions. I want this session to be very, very interactive. So I come from core tech background, and as I give this talk, obviously based on your questions, I also seek to learn from design perspective, because all of us build product, but many times products are successful or not so successful. That all depends on how good the user experience and design is. So usability is one of the very important parameter, and then obviously when we talk about product building, we are talking about AI/ML and this world of big data and cloud, and given to COVID, people are not left much with choice to delay their journey for digitization. So I'll proceed with that. And having some difficult, yeah. Okay, so this is the agenda for today. So I will very briefly touch upon the definition of AI, because considering that people come from diverse backgrounds, so I will just try to take everybody along. Like if you have no background, then also I will touch upon basics, and then we'll go deeper depending on your question and interest. So we'll talk about AI, we'll talk about how we see AI in design and why AI. And again, when we talk about expectations, what are the realities, myths? So some of these components we'll touch upon, and then we'll talk about because as you might have heard that some of the AI system are probabilistic, many times certain things do not work. So how do we talk about responsible AI, explainable AI, is it black box? So some of these keywords we'll touch upon, and we'll see how do we build a system around it, and how design obviously contributes in creation or setting the user expectation. So that's one of the concept. And then we will also talk about some of the market segments. So depending on which industry or business sector you are working into, we'll just see how we'll take some relevant example and how it makes sense for you. And then we'll keep time for question answers. So AI, and this is the definition that is taken from Wikipedia. So AI, as you know, that when we talk about machines to become intelligent, how intelligent? Because typically, as you know, that machines are rule based. So for example, if I have to turn on the fan, I press the button and it turns on. But if I want the fan to understand whether it has to sense the temperature and get on by itself or turn off if I'm finding it uncomfortable or something like that, and I want it to be happening automatically without me defining, right? That is when we think, okay, some kind of sensor data has to be taken, collected, and some kind of automation is to be defined, so that these things can happen as and when we wish them to happen without us very explicitly defining. And so basically the simple definition of AI is whenever we have data, a large volume of data where we cannot define rule. For example, if you see this picture, the door, the wall, and the curtain window, and if I say, can you give me a rule, how do I articulate, how do I write and program an algorithm to identify this particular door or window or wall or this particular scene or color, then probably it will be very difficult for you to articulate. Probably all of us will identify that, okay, window is maybe partially open or curtain is flying out and so on, but it will be very difficult to define rules. Now, a scenario like this, when it's a real life scenario, when we understand but we cannot define rule, we assume that the way we humans learn from data based on our experience in process of growing up, can we create some kind of systems which also learn from data? So basically there are two components, data and algorithm. And these are the two components which define any kind of AI systems. And yeah, so yeah, and this is one of the example where we talk about design. So this is the example I've taken from one of the blog on Medium on design, where they are using when they are designing the components on mobile interface using how people are interacting with mobile, how heat maps you might have experienced, you might have known that how heat maps are used to design websites, right? So some of these examples are there when we cannot very clearly articulate rules. We just know that, okay, if this is how the elements are placed, this is how people will interact, right? And then we use some data, and obviously data is processed based on algorithm. So this is one of the example very relevant to design, but in other scenario also we will see how to link it with design component. So again, why AI? And now in order to justify why AI, I will take you through a lot of data. I will start from early 2000, and I will cover the journey of data and development of technology very, very quickly without spending much time in each of the slides. This is just for you to perceive the journey of where we have come till today. So this is one of the slides which talks about industrial revolution. So in early, basically in 1784, if you see this slide, you see 1784 is one of the defining year for mankind, for human evolution, when steam, power, weaving loom, some of these things got invented. And after that, people got different kind of power, people started to move. So this is like one of the defining year, and we call it Industry 1.0. Then we talk about Industry 2.0, when we spoke about the mass production. So machines were built, and then suddenly, instead of man-made things or doing things one by one, we can create, we can manufacture, right? So this is like one of the empowerment, which is again in 1870. And then after that, in 1969 is Industry 3.0. That's the year that is quoted when we talk about automation, the computer. And suddenly we have so much of power that we can store data in a smaller devices, we can carry data, we can compute, and it gives us a lot of power. And now today, we are in the era of Industry 4.0 when we talk about cyber physical system. And from early computerization, from 1969 to today, we have seen that how things have evolved. And AI is not a new concept. The earlier paper, if we talk about research in AI, they were written in around 50 years ago, more than 50 years ago. But today they are possible just because we have the internet, we have the compute, we have the cloud available. So that's the only difference. And then in 2020, obviously, I mean, we all have different kind of difficulties, but at the same time, from the digital journey point of view for industry, for businesses, suddenly it has created that acceleration that we have seen that we would have taken 5 to 6 years to cover that. So that kind of acceleration and acceptance towards the technology we are experiencing in this particular year. And now in this slide, what you see, this is in early 2000, that when CD-ROM came and when people could store 700 megabytes of data in one CD-ROM, which is equal to 7 1-meter bookshelf. So basically the kind of books that you can keep in 7 bookshelf, 1 meter long bookshelves, you can carry in one CD-ROM, and that's like one empowerment. It feels unbelievable when you see this kind of number or comparison, right? And now going to next. Yeah. And again, this is also a study published in early 2000, where there was a comparison in consumption of data from 1992 to 2000, year 2000. And then you see that some of the digital components, you see the consumption rate is at increase, positive increase, and in case of say home video is like 30%. So it's a large number of video games, you see 146, right? On the other hand, you see the decline in case of say newspaper or books, 10% rate, or maybe in books 4%, right? So you see how people are moving towards digital even early 2000, right? So that was a trend that is observed. And now coming to past few years, so if you see this particular slide, probably you would have already seen that in 2017, and as a comparison to that in 2018, if we publish what happens in 1 minute on internet, then we see again there's a rise. And in certain sectors or in certain companies, we see that rise to be large, right? For example, if you see Netflix, so in 2017, you see 17,000 hours were watched, but in 2018, they become 4 times, right? So some of the businesses picked up very, very fast over the period of 1 year, right? In Instagram, you see that change. And then this is on the software side when we talk about data. And now coming to hardware side, again, this was a study published in 2018 where we see that number of devices, the sensor from the IoT side, they are again on a rise. So IoT device, if you see, so this was a prediction that by 2025, it will be approximately 21.5 billion IoT devices. And non-IoT devices, when we talk about various kind of sensor data like wearable and so on, we see a 34 billion, which is like more than, I mean, many times of human population, right? So that is how the prediction was. And now coming to 2020, if we see the comparison, this is published in the scenario of US. daily data uses by devices in the US in 2019 to 2020, if you see, then again you see that there is an increase approximately 30% higher, right, in the duration of 1 year. This was published in the month of May. Now coming to the study published in the month of June, again you see that there's a data spike in gigabytes, right? And then you see the trend again. This report is published in the, and you can see those URLs for reference. And if you want to know any particular reference points, you can always send a message and I will share the exact URL. So, so this particular study where you see that active internet users, active mobile internet users, social media user, everything is all these four are more than 4 billions, right? So we already have more than 50% of world population active over social media and also on internet, both on mobile and in other devices, right? And then what happens on internet, if you see, then again you see the rise from 2014 to 2020, you see, and approximately 60% of the world's population is there. And so a lot of data, a lot of activity is generated. And obviously when we talk about this kind of data, the only thing we can see is pattern instead of individual maybe parameter, very precise value. And that is when it becomes very, very important for us to understand how AI and ML, these algorithms, process this data and for various use cases, right? And now this is what happens in 1 minute in internet in 2020. And then you see, yeah, so this is what is happening on internet.
Hey, Arpita, I guess we kind of lost you. I mean, your voice is a little feeble. No, still it's pretty low. Yeah, you are still a little bit breaking up, I think.
Okay, I will just turn off my video. Just a second.
Yeah, I think now it's better, I guess. Once you come closer.
Yeah, okay. Yes.
Yeah, now it's better.
Turn off the video so to just maximize on bandwidth. So now you see the data. So I will just sum up what I said so far. I have just given a comparative study that how we have come till here. So earliest number I have shown in 1992 till 2000, we have seen that digital consumption is on a rise. And then we see that in 2017 to 2018 again, we see that digital consumption is on a rise. A lot of data is being generated. The IoT devices, the prediction is that they will be I mean, more than human population many times. So everybody will own more than a couple of devices. So that's the kind of prediction, that's the world we are living in. And obviously when we want to make sense of this, we want to, we talk about using AI/ML algorithms. So, yeah. And this is a research that said that digital transformation has been sped up by 5.3 years that I referred. So basically, I mean, and if I would have spoken to people maybe in 2019 or 2018, yesterday some of the companies, some of the businesses would have said that, okay, we want to delay our, for example, Sunway is into legal sector. We have done software solutions for legal space. So when we used to speak to people in last year or year before that, obviously, I mean, there was a push for bringing things onto digital mode, but still, I mean, certain things could have been delayed. But today, in times like today, there's no choice. So basically, there's no time to resist. It's time to reset, pivot, and think big. So that's the summary of what we have seen so far, and not just because of COVID, because COVID has left no choice for people. But before that, also we have seen that there was a trend towards change. So by AI is very clear that we have a lot of data, people are connected, and every second, every minute, so much of data is being generated, and we have to make sense out of it. And so we have to use these algorithms. But the only problem that happens is that when we talk about expectations or versus reality, I will just try to play one video here. I just pause this share and yeah. Can you see my video, Dhyan?
We're still seeing your presentation.
Okay, yeah. Can you see it now? No, sorry, yeah, I have to pause.
Not yet.
Yeah, okay.
Maybe you might have to
Yeah, now.
share the entire screen.
Can you see it now?
Not yet. Yeah, yes.
Okay.
Hey, Jess.
Hey, Jess. So I'll just pause for a second. So here there are some subtitles which are not in English. So this is this video is from a WhatsApp forward. So this is just a casual video, not a formal one, but it makes sense because when we talk about expectations versus reality and how we design system, it's a very impactful video, and please see it from that perspective.
Smoothie.
Making smoothie.
Calendar.
No meetings today. Remember, tandleke at 9:30.
Fire off.
Fire off.
Open door.
Door open. Sånn. Så skal vi sette en til.
Ja. Open door.
Run voice command.
Open door.
Run voice command.
Open. Open door.
Repeat back.
Open door.
I didn't understand that.
Hey, open door.
Play on the floor.
Get on the floor. Open the door. Open the door.
Error.
Area with a rock. Open door. Open door.
Higher, William. Higher.
Hey, Jess.
Higher, William. Higher.
Yeah, so you saw that when we talk about systems using AI and ML, they understand us, and then, for example, the way the person, when he was stepping down, he said, okay, smoothly, he asked his appointments and so on. It was like very smooth. That's the kind of world we want to live in. But at the same time, if there's a parameter change, for example, the person went for dental procedure and then obviously the voice is changed, then the system doesn't know the voice and the system doesn't work at that point of time, right? So some of these issues come when we talk about designing any AI ML based system, and why it is challenging. I mean, things don't work. For example, if you have a switchboard, I gave example of turning off on the fan in the beginning of my talk. So for example, you know, okay, in your switchboard, there are 4 switches, right? So one for fan, one for light, one for maybe some other thing. And then if you have to turn on the fan, you have to turn on the switch for the fan. But if you turn on some other switch, it will not work. But just because these are machines, we accept it. We accept that it will not work. But when we talk about net to machines using our say voice command or maybe any kind of human like interface or inputs, we have expectations. Humans have expectations that they are understood. They are not able to understand the way if you turn on the light switch, the fan will not turn on. Similarly, if your input is changed, the voice is changed, or any kind of parameter is changed to the system will not work. In real life, we are used to of perceiving or observing that even if there's a minor change in the voice, people around us still understand us. But the same thing doesn't work with system. And that is when we talk about expectation versus reality, where many times people perceive that systems don't work. Not that they don't work, they work for what they have built, for what they have learned. But obviously, if there's a new type of data, new variability, and so on, they don't work. And that is when the mismatch of expectation comes in picture. So obviously, these are probabilistic algorithms. Sometimes they will not work. They will work for 90-95% accuracy. And there's always a chance for 5 to 10% of error. But at the same time, expectations are also from the human side that they should work for the variability that humans perceive, but machines don't, because they are not trained, right? So some of these issues come when we are designing the system, and we have to see how to work around that. And again, from design point of view also, it's a very important question, it's a very important parameter to consider, how to set the expectations right. So if we are designing a system, so that is when it is important to understand and consider these parameters. And here I will give example of one of our feature in our recently launched product for consumer, the consumer.sunwai.in. And we have one of the feature in that particular solution, which is called Vika, which is validation and information for consumers assistance.
Anvita, sorry.
Yeah.
Yeah, I mean, sorry to cut you. So are you sharing your presentation? Because we still see the video.
Oh, you can't see. Oh, okay.
Oh, yeah, I think now we see it. Yeah.
Yeah, now you can see, yes. Yeah. So, yeah, so I think there's some delay in the network, sorry. Yeah. So from the this particular example in our solution, Vika. So initially what we had done was for validation of a consumer issue. So basically the problem statement is that if people have any consumer issue, they want to know whether the issue is legally valid or not, right? So, and if issue is legally valid, if they are unable to get it resolved, then probably can they seek for any kind of legal remedy? And what should be the remedy? So that is the question that people want to know the answer for, and for which they go to lawyers. So obviously for any kind of complex question, lawyers will answer, but for any kind of simple question, the data can be processed and machine can answer, right? So that's the premise. And now for that particular premise, what initially we designed was, we designed an interface where people can come and they can just type their problems. So I come and I type my problem in 1 or 2 lines or 1 or 2 paragraphs, and the system processes that particular natural language written by me and gives me the answer. Now these are probabilistic algorithms. So obviously answer is my algorithm is 90+% accurate.
It's 4:30.
Now 5 to 10% chances that there are errors, and there will be some kind of matching errors, and the wrong answer will come. Now say suppose if I'm the user of the system and I come to the system and I have a problem and I define my problem and system gives me the wrong answer, I feel frustrated, right? So here obviously I'm in desperate need, and then if I'm not getting the right answer, I feel frustrated. So I feel frustrated and immediately my trust from the system will go, right? So probably I will not know that, okay, 90% time it works very well, only that 5 to 10% time it's giving me error, but probably I will never want to use it again, right? So how do we do that? Then immediately we realize that we have to work around the expectation of the user, and we will change the interface. So now for this particular scenario, we have removed that interface where people can type in their natural language. We have changed the interface where people can self-validate themselves just to maximize on the accuracy. So we have created this interface where people can press button and they can read, they can validate. So basically somewhere we are mapping what they can write in the free flow text to some kind of predefined interactive interaction with the system. And so basically they can get 100% answer. At any point of time, if people are confused or the system is not able to understand what they are looking for, the system anyways gives an answer that, okay, when the accuracy is low, system says that talk to the lawyer or read the law and so on. But as far as system is able to understand, it will give you 100% answer. It will not give you anything wrong. It will not guess. So basically, the user should not feel frustrated. That's the basic point. But there's another feature where we talk about people being able to search the information, the legalities, the formalities, the requirement. Then they can type in their natural language, the plain English, and the system is giving match. And obviously then we are displaying results based on relevancy. Then there are 2, 3, 4 answers are coming, and then people can read. So because they can see all these information together and they know they don't have to go by just one single answer. If the first answer is not exact match, they can go to the second, the way we do Google search. So in similar manner. So here, the design aspect or talking about the user expectation is very, very important when we talk about designing any system using AI ML, because we have to understand that these are probabilistic algorithms. They are not 100% accurate. They are likely to fail. And when they fail, in what scenario they will fail? And we have to very clearly consider the scenario. If I have to take example of the video, suppose this video everything is voice based. Now, if I'm the designer of this particular solution, and if I know that if there's a possibility that person has a bad throat, or maybe in case of dental procedure, the voice is likely to change and my system will not perform. Now, in that particular scenario, do I have a backup interface, right? Can it work using fingerprint? Can it work using facial features? So some of these kind of backup systems we have to design. And these will be different components of the system. Obviously, they will be expensive. There will be effort required to create them. But then that is how we create the completeness. And that is when we maximize the expectation of the user. So designing of features is very, very important when we talk about systems using AI ML, considering user expectation, because users should not feel frustrated. And if there's a need, if there's an interest, I will also talk about behavior model towards the end of the chat when we talk about the expectation of the user. When we talk about parameters like motivation or ability to design the system. And this is another example, one of the projects that we have done in past. So, yeah.
Yeah, I think, yeah, so we still see the presentation. Yeah, the slide.
Yeah, it is the same. Yeah.
Okay.
Yes. So this another example that I was going to talk about was collecting data using in the remote village scenario, using voice-based reporting and authentication by volunteers in the village. So now when we try to design this particular system, again considering the probabilistic nature of AI ML algorithms, what we decided was that we will not do authentication based on voice, because there will be a lot of background noise and so on. So we'll do fingerprint-based authentication, but we will do voice-based reporting. And reporting, obviously, when somebody is speaking and the data is being captured by the system, and then again it is converted to some textual format and is stored in the backend. And there will be some kind of error in the conversion, but they can be curated, they can be manually rectified at a later point of time, because this is not a real-time scenario. So then we can do, but authentication has to be fingerprint-based, because if we do voice-based authentication, there will be more chances of misidentifying a person or maybe rejecting the genuine person. And then it should build up the frustration of the user, and which we wanted to avoid. So we decided to design it this way. So this is when we consider the probabilistic nature of the algorithm. And I will go deeper if there are questions or any particular specific use case. Yeah. So, and here I have not shown any slide on responsible and explainable AI, but this is a very basic fundamental that we follow when we talk about responsible and explainable AI, because the system has to understand what user expects. The system designer or the person who is engineering the system has to understand when it is likely to fail, and for what particular scenario, what particular data. And then I have to decide, either I have to inform the user that, okay, in these scenarios, it will not work, so please don't have expectation, or I have to design a larger system which takes care of the alternate scenario for which the system 1 is not designed, and then I have a backup system, plan B kind of system 2, which takes care of the second scenario. And then basically it's all about designing the complete and responsible system, giving setting expectation to the user, and also understanding the explanation, why it is working and why it is not working, right? So that is very important. And then we will just take very quickly some of the examples of different market segments and specific business sectors. So roughly, if I have to divide market into some kind of segments, then we see high technology market. So most of the examples that I have shown in the beginning of my presentation, Facebook, Netflix, so all they come into Amazon, Google, they come into high technology market, and where we know that we get solution, we get search in Google, we get result in Google search, we share picture and people get in on Facebook and our friends are able to see. But then here we strive for perfection, because again, these algorithms will be working with some accuracy, and whatever minor errors are there can we perfect them, can we further better them, and that is where the engineering effort is required, and that is how maybe some kind of design elements are also placed to set the expectation of the user appropriately. Then we talk about traditional businesses. So banking, for example, has been a traditional sector, and now with fintech, suddenly the sector has seen the drastic change with digital payments and so on. And then the third kind of example, where I have given example of this rural voice-based recording solutions in the space of say agri-tech, all they come into emerging market. So these are all the three markets. Technology is, we still have data, we still have sensor-based data or software data in the digital format. And at the end of it, there's a pattern in the data that one has to capture, and for a particular business objective or business goal. And then coming to particular sector, again, these are the sectors: retail, healthcare, education, public safety, transportation, banking, manufacturing, and many more. These are just some of the sectors I've listed here. And some of the sectors are very generic. Like if you talk about healthcare, again, in a high technology market, you can think of a different kind of solutions. For example, say one of the project that I have not personally worked into, but it was discussed by one of the teams, that for say one of the say I think knee replacement, because they do not know the correct size of the new cap to be put. So they have like some variable sizes to be designed, and then when they open the bag, one of them actually fits to the person, and the remaining basically are not used. So can we do any kind of modeling of this particular human body, human bone, and can we 3D print the exact correct parameter which fits, which avoids the wastage? So this is one of the example of healthcare solution in a high technology kind of market. But if I talk about any rural market, rural scenario, or traditional scenario, then we'll think about a different kind of business use case and solution. And again, based on what people are perceiving, what kind of requirement. For example, you might have studied Maslow's hierarchy. So depending on which particular sector, which particular market segment you are serving, though that based on that, what are the requirements of the user? Are these requirements related to very basic fundamental physiological needs, or they go towards luxurious segments and so on? And then based on that, what will you serve? So that is a question one has to answer. We talk about education, like today, most of the children are studying at home. And then sometimes they are not impactful, right? Some of the sessions, for example, many times we face these delays, like even in this session, we see that sometimes there's a network delay, voice may not be very clear. Then are people on the other hand able to follow or not? Then so can we perfect it, right? So some of these scenarios are there where we already have solutions, we have to create further better solutions. And when we talk about AI ML, obviously we know that technology has its own limitation. For certain things it works perfectly, for certain things it doesn't work. And then how do we define user expectation? How do we say how do we make sure that there's a very good workaround so that people do not feel frustrated when they are using the system? And yeah, so this is like my last slide, and I will either take questions or I will talk about behavior model depending on what the interest is. So basically, I mean, for designers, this is my open question, and this is the answer we explore every day as and when we design the solution, that how to set user expectation with design when we talk about AI ML based applications. Because here there are two elements, one basic fundamental design concepts, which are their user experience concept, and now here additional parameters, the system themselves are probabilistic, the algorithms, the solutions themselves are probabilistic. So what is the additional layer that we add when we design the system so that we create maximum comfort for user our system become more and more usable.
Yep. So I think we still have 20 minutes. So if you want to deep dive into this portion, yeah, it'll be good. Or we can jump into questions.
Yeah. So I wanted to talk about behavior model. I don't have a slide, so I will just orally talk about this. So this is a model that is studied by Dr. B.J. Fogg at Stanford. And he spoke about 3 parameters when designing systems for modeling human behavior, persuasive design, and which I thought will be relevant for the group. So he spoke about 3 terms. So let me just orally define those terms. One is motivation. So people do something and they are motivated. So behavior is exhibited, or the task is performed when people are motivated to do something, right? Or they have the ability to do something. And then triggers are the one which enable the task to happen. For example, if I want to go somewhere and I also have the ability to go to that particular place, then the only thing I want is I just want to set an alarm to my phone or the watch, so that I know this is the time for me to go, and I will go because I have the motivation and also the ability. So the only thing I need is a signal or a reminder. So the trigger is here that enables that behavior to happen is signal. And then he further defines that on these 3 parameters, when we talk about motivation, ability, and trigger, so trigger is what makes the behavior to take place, the task to happen, is basically a good combination of motivation and ability. So motivation, for example, some of the parameters that define motivation is like fear or hope. So if I'm hopeful to do something, maybe if there's a lottery or there's a reward point or something, then people will participate in that particular contest, right? So there's a hope that I may get the prize, right? And for that purpose, I will participate. So the trigger that enables that is some kind of spark, which says there's a hope, or opposite to hope is fear. So for example, if you are booking your ticket in any of the online platforms, say plane ticket or any kind of tickets, and say not in today's scenario, but in general, if it says only 2 tickets are left or prices are going to go high and so on, then you end up booking it at that point of time. Otherwise, you would have delayed that particular decision, right? So yeah, so I'm just sharing my video. Yeah, so you would have, otherwise you would have delayed that particular decision. So the parameter that enables that particular behavior to take place or task to happen is hope, the motivational parameter, or the fear. But on the other hand, motivation is temporary. It's like very one time. Okay, today I want to get something done, so either I will create some kind of hope or I will create some kind of fear. So most of the design elements, most of the strategies are defined around the motivation parameters. But what actually works in the long term, motivation is very temporary. Like today, if I get some reward, I will do something. Tomorrow, I get some reward, I will do something. For example, you talk about fitness band that people wear. So today, I will get some reminder, I will do something. Tomorrow, I will get some kind of trigger that sparks me that yesterday I did so much of walking or running, and today I should also meet my activity goal. I will do that. But over a longer period of time, the motivation is not sustainable. So motivation dies down. And that is when we talk about ability. So ability, again, there are various parameters that define ability for people. Money is one of them, time is one of them, brain cycles are one of them, routine. Some people are very good in doing routine things, but if things are out of routine, they find it very challenging to follow. So some people, so these are some of the social deviance. For example, if things are socially acceptable, it will be very easy for one to get into that. But if things are little one-off or kind of odd, one feels kind of odd man out, then people will not get into that kind of thing. So when we are designing any kind of solutions or systems, we have to basically play around the motivational parameters, which define any kind of positive or negative emotion which are triggered into people, or ability parameter. For long-term sustainable solutions or habit-forming kind of products, we talk about ability parameters which are related to ability. Can we facilitate something? And that is when the third kind of trigger, I spoke about 2 triggers. One is like signal, where we talk about we are motivated also, and we also have the ability, we only need the reminder or the signal. The second trigger that I spoke about was Spark, where I said people may be low on motivation but high on ability. And then if you spark something, you say, okay, there's a reward or there's some kind of fear factor, then people will do the task, right? So that enables the behavior to take place. And the third parameter, where people are high on motivation but lack ability, right? When they are low on ability. And that is when the third kind of trigger which is required is called facilitator trigger. So I spoke about that when I was giving these project examples, one from Sunwai and one for the rural scenario, that if I use AI ML algorithm, for example, if I would have used AI voice-based authentication in the rural scenario, and the authentication gets rejected multiple times for a volunteer, for a healthcare volunteer, the person will not be motivated enough to try out the system many times, right? So that is when, in order to create ease, can I create a system where people do not feel frustrated, right? Can I facilitate? And that is when we talk about facilitation, we see, okay, how to minimize the request rejection. What is a better parameter to select? What is a better algorithm to select? What is a better sensor data? Which sensor data to choose? Whether the sensor data is coming from the microphone, the voice-based data, or is it a fingerprint sensor-based data, right? So some of these are defining parameter for us to understand when we are designing the system, especially in the case of AI/ML, whether people are lacking on motivation or ability. And then depending on that, which kind of triggers are to be created when we are designing the system, so that the business objective, the end goal is met. So can we facilitate things for long-term kind of sustainable solutions, or for one-time tasks can we spark emotion and enable some behavior to take place, or in general, day-to-day, how do we create signals? So this is one very important parameter for designers to probably you would already be considering, but yeah, I just wanted to put the scientific parameter around that. Yeah.
Yep, wonderful. So Amita, so how does this going to impact this the concept of in general the design education itself, right? So today, like let's say we call this thing called user interface designer, but there's no more interface when you're trying to do a voice-based solution. So how is that it's going to change the way how the designers are going to see in the future?
So still, I think a lot of design elements will be required. It's just the way we work will change, because I mean, if I talk about early days, say if I talk about my Oracle days, that time itself, I mean, developers think, okay, we are the developer and we know everything, and then there's an automation team which finds fault, and then there's a design team, and then obviously, I mean, everybody has a perspective, and we have to come together and work together. Now, in today's scenario, when you talk about voice-based interface and so on, at the end of it, it's still a system which is taking an input. Instead of button press, maybe you are speaking, and instead of button press response, which is like more accurate until some button press event does not take place. Mostly you press a button and things will take place. But in voice-based, the probability of failure is further higher as compared to the button press event. Let me put it in very simple manner. So still you need to understand the user behavior, the user response, how people feel. Now, when people are interacting in more real kind of scenario, how they feel becomes more and more accurate, because when we press a button, the kind of emotion I think are triggered as a user to me. If I'm pressing a button, still I'm prepared to press a button. I know that I'm pressing a button and things will happen. Sometimes they don't happen. Sometimes there's a delay, and somewhere I'm prepared to handle that delay, right, internally, but psychologically. But if it's a voice-based interface, and then I'm speaking and doesn't understand, probably I will not try until there's a very important need, right? So it all depends on what kind of system it is, what need I have. So the hierarchy of need is again very, very important for us to consider in designing the system. And yeah, so yeah, understanding human emotion is very important. And somewhere I feel that and there's already a research around emotional computing. So some of these algorithms are taking place in development. and we have to just figure out new ways of working and understanding data, how people are responding. So for example, if I spoke and people, my system did not respond, how did I feel? Did I try again? Did I not try again? What kind of people tried again? So some of these data points will be important for designers to consider for set understanding, I mean, what when you design the solution.
Yep. So kind of an extension to the previous question. So so definitely this is going to have a huge impact on the typical user research, what the design people do, like all those ethno studies and gorilla test and doing a usability testing, right? Because now it's all data driven, right? So I mean that speaks the truth. So how do you see that that also having a huge impact on the research side of it?
Yeah, so I think some of the Apple, the way they design systems, so some of those stories can be relevant here, can be considered, but mostly it will be because even now system building is more into data driven. So as opposed to traditional way of building system where I say, okay, this is the system I'm going to build. Here I analyze data first. So I take the data, obviously there's a purpose, but at the same time, the purpose is not defined by me through algorithm as a first place. Here I have the data, and then I decide which algorithm will understand this data, right? So that is a little opposite way of looking into data. And same for design also. I think because I'm not so well versed of some of these methodologies that designers use, but that is how methods will be evolved. Like heat map is a very good example. When you wear the camera and you do the eye tracking, then you see how people are looking at one of the pictures I have seen that where it was an example of, I think, some of the baby product. Then the baby is looking in the front, and then people are not paying attention to the brand name. But if they turn the baby face to like sideways, then they know that you are not looking into baby emotion, the cuteness of the face. Then immediately the attention goes into the brand name, right? So now some of these things, how do you do eye tracking? And again, when you do eye tracking, you are very much utilizing that data of the AI/ML data, which is processed by the algorithm.
Yep. So I think we have a question from the audience. So I think which is also like kind of sums up like what even I want to ask. Like, so what's the best way to like quickly learn this AIML thing, right? So what are the different technical aspects that a designer need to know so that they can actually challenge the ML engineers, right, when they try to work with them. So any basic things which they have to be there, because let's say a lot of the old school designers are there and there are this new age designers are there, right? So any tips for them like that can bring up to the speed?
I think designers are already like so well equipped with that strength when it comes to emotions, so which I see that many times system engineers do not have. So that is a plus. When you talk about building solutions using AI/ML, that's like already you have that attitude, right? But at the same time, when it comes to tool and working together to build a solution, then the only sensitivity I think designers should have is that you understand the probabilistic nature, the kind of research that goes into building the solution. So that little empathy factor becomes important for us to work together. And you don't have to learn AI/ML, you just have to know how it works, right? So because as a designer, when you are giving your inputs and you say engineer should do this, then again it is not in control of engineer, because again it's in control mostly of the algorithm outcome that is generated by the algorithm, right? It's a probabilistic.
Totally.
So so how do we play around that? How do we think around that? And how do we think constructively so that the purpose is, the end objective is, how do we soothe our end customer, who is the user of the system, so that he is at minimum discomfort. Obviously the person has the discomfort when the system doesn't work for whatever percentage, like 2%, 5%, 20%. So how do we create that, right? And that is when the design philosophy, can we create some kind of soothing factor using colors or using giving the right messaging. Engineering side, obviously engineers have to take care, but yes. So from system point of view, I think you don't have to learn AI.
Got it. Yep. Cool. So I think just a couple of questions, and I think we should be good. Yeah. So you also spoke very nicely about the way how there's a customers dissatisfaction, and so we try to like set the expectations right. So so I see that there are like a lot of elements here, right? When somebody is going to build this smart product, so we have the engineers, and then we have the product owners, and then we have designers, and then we have this AI, right? So anybody can utilize that. So so how does, so who owns this, or who is the best person to try and advocate the best usage of this AI, right? So just a little bit of any insights on that, as so when anybody's trying to build a product, so where do you see that so should the push come from the any of these players, or is AI pushing these people to think something beyond what is needed?
I think the push is from the data, the volume of data that we handle. Because when there's large volume of data, obviously you cannot define rules. So, so basically that's the defining parameter. So let me give you this example. I've also worked on one of the algorithm for one of the banking customer, large banking customer, when more than 10 years ago, when online banking was new. And the business objective was how do we maximize authentication in online scenario when people are doing fraud. So basically loss to bank is minimum, because if I'm as a user logging in and somebody is doing a fraudulent activity and the bank has released the fund, then, and if I have also claimed in parallel that, okay, if there's a fraudulent activity or my card is stolen or something like that, then obviously, I mean, I don't have to pay, the bank has to pay, right, if money is already released. So
Right.
loss to bank has to be minimum. So how do we authenticate transactions using human behavior, the way people interact with online system, right? Can we see a pattern, and based on that, can we authenticate so that with good accuracy? And then I have done this algorithm where accuracy was up to 83%, 83% accuracy, the transactions are authenticated. And yeah, the defining parameter was because you can't see the user, so you can't read facial features. And now today you can still see, okay, you can say, okay, I can set up a camera, internet is fast and so on in certain areas. But in that time it was not possible. And then the only thing we had was the clickstream data, the user behavior data, and what buttons they are pressing, how they are putting information, with what delay they are putting information. Some of these parameters were there for us to consider, and data becomes a defining parameter here.
Yep. Okay, last question. So, do you think will AI replace designers?
No, AI will not replace anybody. It's just that the kind of work we do will be replaced.
Got it.
Yeah. So because a lot of work which are very monotonous, so you don't need humans to do that, because you can build systems for doing that. Like if I have to talk
It's
about my examples from if I go 100 years ago, maybe 150 years ago, you see before electric fans, like humans had to do the fan, right? They had to like pull the string, and there was a fan hanging on from the rope. You might have seen in the movies. Then electric fan. So it did not. Maybe that particular job is killed, but still not that people didn't have job. So similarly today, and the new kind of jobs will be, which will be very, very important for us going forward, at least in near future, or maybe in not near, maybe medium duration. Understanding data, defining data, labeling data, some of these, because algorithms are based on data. And if data is not collected rightly, if data is not labeled rightly, though we do a lot of unsupervised processing on the data when we are building system, but in certain cases, we still need humans to validate the outcome of algorithms, because in the process of system building. And if that validation is not done correctly, then obviously, I mean, nobody knows what's happening inside. And that is when the law comes in picture. And some of these things are already in debate, and laws will come in place when we talk about concepts of creating responsible system. So again, like if you talk about autonomous vehicle, say there's again a probabilistic error. So if you are going in a car, you are driving by yourself. Obviously, you can also make a mistake. If your driver is carrying you around in a car, he can also make a mistake. Now there's a self-driving car. The algorithm can also make a mistake. But in case of genuine accident, you still know there's a driver who was drunk or not drunk and so on. But in case of algorithm, how do you figure out whether it's an error by algorithm or by a network delay, or by just because the data was labeled wrongly by a person who was dealing with data, right? So instead of the vehicle picture, the person took picture of, say, cow. then that cow, the model was trained on the cow picture, right? So how do you know, right? So,
Yeah.
so how do you define? So who is responsible? So some of these things are there, and still there's a lot of human intelligence is required for any of the solutions building. It's just that monotonous part, or and just because you can't define rules, so that is when
Yep.
you take help of AI.
Absolutely. Yep. Well, yeah, I think we're almost on top of the hour. Thanks once again, Anvita. It was an honor having you on the show. And yeah, I think it was a great insight in terms of giving us a refresh on AI, and also getting a little bit deeper into like what is needed for from designer's perspective, right? So yeah, thanks once again. Thanks everybody, and have a wonderful weekend.